Hello, good morning. I'll be talking about our project as part of MEOPAR and several other agents such as Ocean Networks Canada, Canadian Space Agent, and HACI. My name is Maycira Costa. I'm the PI of the project, together with Laura Cowen and Yyvonne Coady from UVic, Brian Hunt from UBC, and Julie Laroche from Dalhousie University, and many HQP, postdocs, PhD, master's, undergrad, and part-time students involved and technicians involved on this project. So our goal is to better understand the dynamic of the BC and Southeast Alaska coastal region. And one of the steps is define those biophysical regions or province and investigate how these provinces change according to the different bottom-up drivers and how can we translate this knowledge into product that can be accessible by government, industry, and other partners. So the first step on the bioregionalization or the division of provinces, we use satellite data, especially data from Sentinel-3, which is an European Space Agency data, and a lot of in situ data from different platforms, sensors installed on the BC ferries measuring water reflectance, and sensors also installed aboard of the Royal Caribbean cruise ship, Celebrity Solstice. Last year, he is showing the installation of the sensors, and these sensors aboard of the two ships of Opportunity collect water reflectance data, showing here on the plot in dark, and this is measured after atmospheric correction by Sentinel-3. So we use this data to validate the radiometry of Sentinel-3. And after that, we derive products using specialized models to derive chlorophyll, total suspended matter, and dissolved organic matter from this region. These products are all validated as well. From that, we have this large amount of data set to process on a daily basis. We do that using Compute Canada, and we developed this application called Algo Explorer, which is a web-based application that you can visualize chlorophyll products on a daily basis, but we can also store data in Compute Canada. This data is further used by the members of this project to define phytoplankton phenology. This is student of a new postdoc, Christian Marquez, and he is using self-organized maps to derive what could be the biogeochemical regions based on phytoplankton phenology derived from Sentinel-3 data. Student Patrick Pata from UBC is actually looking at a slightly different type of data set, looking at in situ zooplankton and also define bioregions based on zooplankton. Later on, the idea is to merge the phytoplankton phenology with the zooplankton phenology. Further, we look at phytoplankton groups using HPLC Cantax data and satellite to derive phytoplankton groups from this region based on satellites reflectance. This is ongoing research. And we further use a holograph microscopic data, which the holograph microscope was installed in the BC ferry last year, and now the library is being developed that we can later on use to validate the satellite phytoplankton groups product. And finally, in parallel to all of this, HQP is looking at the synchronicity between zooplankton and phytoplankton. And this is work that Dr. Suchi, postdoc Suchi, is doing as a continuation of the MEOPAR Part 1 that we had. And she continued doing as part of MEOPAR Part 2. So here she is looking at the synchronicity between different stages of development of euphasis, which is an important food source for salmon, and chlorophyll satellite derived climatology. So you can see there is a very synchronous phase for both the chlorophyll and the development of different euphases. She also evaluated that depending on if you have an early or later bloom or a normal time of spring bloom happening Salish Sea, you have higher abundance. In parallel to that, PhD student Rajib is looking at how to improve fisheries models, salmon forecast models. So she is looking at the Ricker model and applying CSST derived from satellite and chlorophyll to see if she can improve the predictive approach for the Ricker model. Thank you very much.